Okay, so a quick overview on probability and a couple of different types of probability questions. So first one is a two-way table in which we are adding the numbers on the top to the numbers down the side. I filled it in here. We should be able to fill this in. If I look at any section here, 4 and 3, for example, there, that will give us 7. Okay, so you're adding the number on the side to the number on the top. Okay, calculate the probability of throwing a total greater than 8. So greater than 8 doesn't include 8. It includes 9, 10, 11, and 12. Okay, and if you look at there are 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of a total 36 numbers up there, and that simplifies down to 5 over 18. And we should be always looking for the simplest fraction. In a game of craps, if you throw a total of 7 or 11, so if I circle all of the 7s and 11s, okay, I actually have 8. So I've got 1, 2, 3, 4, 5, 6 7s and 2 11s. So 8 out of 36. Okay, and remembering that we should be looking to get that in our simplest form, so 2 over 9. Okay, the next one, and these are hugely important, okay, is Venn diagram questions. A group of 60 people were surveyed to find out whether they had visited America, Britain, or Spain. 23 had visited America, 22 had visited Spain. Okay, so 22 had visited America, 23 had visited America, 22 had visited Spain. Correct? No. Okay. So, for starters, when I'm told 23 had visited America, that is 23 people in this entire American circle here. Okay, so that accounts for all 4 parts of that circle. Okay, when I'm filling out a Venn diagram, the first place I should always start is in here in the middle. Okay, so all 3. And I'm told the 4 had visited all 3. So 4 goes in there. Okay, and then I work out. So then I start into these sections here. Okay, and the last ones I do is the biggest one. I have here that 9 visited America and Spain. Now, America and Spain is this whole section here. Okay, America and Spain. We already know that 4 people visited America and Spain because they visited all 3. So in visiting all 3, they have to have visited America and Spain. So there must be 5 people over here that had visited America and Spain, but not visited Britain. Okay, so we've got 5 and 4. Then I have 10 people had visited America and Britain. Now, America and Britain is this entire section here. Okay, I know that 4 people visited America and Britain already in visiting all 3. So there must be a further 6 included in this section that visited America and Britain, but not Spain. Okay, I'm then told that Y had visited Spain and Britain, but not America. So because it says but not America, that means it doesn't include that middle section. So Y had visited Spain and Britain, but not America. That is simply just this section here for Y. Okay, 4 people had visited none of these spaces, and that's an important one because that can always be filled in as well because it's not affected by the circles, and that's one that people forget a lot, which messes up the maths in the questions following. Okay, now my last places are the larger circles outside. 23 had visited America, so 23 are in this full American circle here. Okay, so I already know that there are 6 and there are 4 and there are 5 people accounted for. So there's actually only 8 people left for that section. Okay, and that 8 people visited America only. Okay, so didn't visit the other countries. 22 people had visited Spain. Okay, now remember that's that entire circle. 22 people are in this entire circle. So we've 22 minus the 5 minus the 4. okay, which leaves us with 13. And I also have to subtract the y. Okay, so 22 people, minusing the 5 and the 4 that are already in that circle, and minusing the y. So I'm left with 13 minus y. 36 people had visited Britain. I've already accounted for 6 and 4 people. And I've already accounted for y people. So 26 minus y. And being able to fill out that entire Venn diagram is seriously important, okay? Being able to fill it out properly and read this information, okay? So you've got to read it carefully and literally, okay? It then says to solve your Venn diagram, use your Venn diagram to solve for y. Everything in there should add up to 60, okay? Because he says 60 people. All add to 60. Okay, so all sections. So if I take the 4 from the outside, plus 8, plus 6, plus 4, plus 5, plus y, plus 13 minus y, plus 26 minus y. So I've literally taken every single section, added them together, and it should equal 60. So when I add these up, I say 4 plus 8 plus 6 plus 4 plus 5 plus 13 plus 26. So I can add all of my like terms. Okay, all the numbers are like terms, so I can add all of them. That gets me 66. Then I've got y minus y is 0, minus y is equal to 60. Okay, and then your algebra here should be able to take you the rest. Subtract 60 both sides, add y both sides, and I will get 66 minus 60 is 6 equals y. Okay, which means I can go back up here, and 13 minus y, okay, is now 13 minus 6. Okay, so we've got 7 in here, and 26 minus y is now 26 minus 6, which is 20. And in here, in this section, I now actually have 6. Okay. What's the probability the student chosen at random had visited only one country? Well, only one country, okay, is the 8, the 7, and the 20, because those people that are not in the middle sections had only visited, that 8 people had only visited America. 20 people had only visited Britain. Okay. So I have a total number of people, first of all, 8 plus 7 plus 20. Total number of people that visited only one country. That is 35 people. And to make it a probability, I put it over the total, 35 over 60. Okay, and it's good practice with probability to get it down to a simplest form, which is 7 over 12. Okay, those Venn diagram questions, make sure you can do them. Make sure you can fill out your Venn diagram. Make sure you can solve it for unknowns, and make sure you can read information carefully. Okay, next question was nice and easy. It asks you to list all the possible outcomes. Well, the fundamental theory of counting tells us I have 4 outcomes here, 3 outcomes here. So 4 times 3, I must have 12 in total. Okay, you can do these however you want. You can make a 2-way table if you want. 2, 3, 4, and A, B, and C. And you can do it that way. You can have 1A, 2A, 3A, 4A, 1B, 2B, 3B, 4B, 1C, 2C, 3C, 4C, or you can simply just name them. Some people did 1A, 2A, 3A, just listing and so on. Okay. What is the probability that the outcome is 2C? Well, I only have 1, 2 and 1C, so there is only one possible outcome out of a total of 12, so 1/12. What is the probability that the outcome contains an odd number? Well, I've got 2 odd numbers, but I've only got one letter A, so there is only 2 outcomes. So 2 out of a total of 12, which is 1/6. What is the probability that the outcome includes the letter C? Okay, well, if I go back up here to my outcomes, includes the letter C, I've only got one of them. Okay, but each C can be matched with a 1, a 2, a 3, and a 4. Okay, so I actually have 4 C's out of 12, or 1/3. Okay, these tree diagrams can be tricky. The English language edition of Scrabble contains 100 tiles, 98 of which have a single letter printed on them. There are 42 vowels and 56 consonants. To make the game more difficult, the 2 blank tiles are removed. The board game starts with each player picking tiles from a bag containing 98 tiles. When a tile is picked from the bag, it is not replaced, and that's important. First player picks 2 tiles from the bag, complete the diagram to show which possible outcomes and fill in the boxes in which represent the probability vowels or consonants will be picked. Okay, so the letters, I've got 42 vowels out of 98, okay, which means all of the rest have to be consonants. So 56 out of 98 consonants, okay. Now, in the second time, okay, one of these tiles has been removed. So this is the first choice. Okay, that's how our tree diagrams work. And this is the second choice. Okay, so for the second time, I no longer have 98 tiles because one of them is gone. I've used one. I now have 97. So all of these probabilities should be out of 97. Okay, in this case, okay, if I've picked a vowel, okay, so here, this going this way, I've picked a vowel. So now there can only be 41 vowels left because I've already picked one. But there's still 56 consonants because I haven't picked a consonant if I'm up this side. Okay. In this case, I have already picked a consonant. Okay. So let's say this is my, going this direction is a vowel. And we'll say this is the consonant. Okay. So I haven't used a vowel already. So there are still 42. I have already used a consonant, however. So this is down to 55. Okay. So in this section, for this probability, it would be a vowel, a consonant, vowel, consonant. Okay, and the way it works, this one would be 2 consonants, this one would be a consonant and then a vowel, then a consonant, a vowel, and a vowel. Okay, and these are tricky tables to figure out because you really have to think about what's happening. It says, find the probabilities that they are either both consonants or both vowels. So I'm looking for both consonants or both vowels. So if they're both vowels, if it's a vowel and then a vowel, okay, that means I have 42 over 98 and remember the and is a multiply, and 41 over 97. Okay, so the probability of getting 2 vowels is 42 over 98 times 41 over 97, okay, which is 123 over 679. The probability of getting 2 consonants is 56 over 98 and, okay, so remember I need both of them, and 55 over 97. So 56 over 98 and 55 over 97. Remember, and means multiply. Okay, and then I want one or the other. The word or is add. So 123 over 679 plus 220 over 679. And I have 49 over 97. Okay. Find the probability that at least one of the tiles is a vowel. Now this at least one, okay? The only option where it's not a vowel is if it's a consonant and a consonant, okay? Which we just calculate the probability to be 220 over 679, okay? That's the only one where there is no vowel. In every single other probability, in every single other situation, there is a vowel. So 1 would be the total probability. So just subtract the 220,679. So 1 minus 220 over 679, and you will get 459 over 679. Okay, if you're looking for at least one, usually find the outcome where that one is not possible, where you'd have none, and then you can subtract it. Alternatively, you could have found the probability of the vowel and the vowel, which we had was 123 over 679. You could have added it to the probability of a vowel and a constant, so 42 over 98 plus 56 over 97. So for the vowel consonant, it would be 683 over 69. Sorry, multiply, apologies. That would be this probability, if you were to calculate for here, one and the other, so 42 times 56 over 97, you would have got 24 over 97. And if you wanted the consonant and the vowel, you would have said 56 over 98 plus, multiply, because one and the other to get the consonant and then the vowel, times 42 over 97. So remember, and means multiply, which is 24 over 97. So you could have also found out the three probabilities and added all of them together. Okay, and you would have got the same answer. So remember, if you want two things to happen at the same time, okay, simultaneously, that's when you've got to use and. So you need one and the other to happen if they both have to happen in order to get to your outcome. Okay, but if you just want any one of them, so any one of these will give you one vowel, or will give you at least one vowel. Okay, so you can use or, which is plus. Okay, and Sinead.